Hello students, welcome back to OrganiChemVerse. In this video, let's learn hybridization of carbon in alkanes, alkenes, alkynes under 10 minutes. So, what is hybridization? Hybridization is mixing of atomic orbitals of central atom. So, in hydrocarbons, the central atom is carbon. So the carbon will undergo mixing of atomic orbitals to form a brand new hybrid orbitals. What is the property of these hybrid orbitals? The hybrid orbitals will have same energy, same shape, and they will have same number of electrons. When they share these electrons with the incoming atoms, then they are going to form new covalent bonds. That's the reason why the carbon will undergo mixing of atomic orbitals or hybridization. What is the importance of this hybridization? It helps us to know the shape of the molecule, right? The geometry of the molecule, the bond angle, and even the reactivity of the molecules. Let's see how carbon will undergo hybridization in alkane molecule like methane, ethane, etc. The carbon in alkanes is sp3 hybridized. So how do we explain that? There is a systematic way you need to follow. First, you write down the number of electrons in carbon atom. That is 6, right? It's same as its atomic number. Now, how do you distribute these 6 electrons? Or we also call this as electronic configuration. The electronic configuration is 1s2, 2s2, 2p2, right? So students, remember, in hybridization, only the valence shell orbitals or valence shell electrons will be involved, not the inner shell. So eliminate that. Now, let's distribute these electrons in the ground state. You know that there is only one orbital for 2s and there are 2 electrons. So distribute those electrons. In case of 2p subshell, there are 3 p orbitals, px, py, pz. You might have learned this in atomic structure, right? So now anyway, there are 2 electrons here, right? So this is a ground state electronic configuration. But when carbon is approached by other atoms, like in case of methane, 4 hydrogen atoms, when they approach, it undergo excitation because the energy is increased. So you see each orbital is having 1 electron. Here 2s 1 electron, 2p, x, y and z. All of them have 1 electron each. Now for methane, since the carbon is approached by 4 hydrogen atoms, right? The carbon must be ready with how many hybrid orbitals? 4 hybrid orbitals. For 4 hybrid orbitals, as I told, we need 4 atomic orbitals. What are the 4 atomic orbitals we are talking about? These. So there is 1 s and 3 p orbitals. So 1 plus 3 would be equal to 4. And what type? It is S1p3 or simply sp3. So we got 4 sp3 hybrid orbitals. So what are the properties of these hybrid orbitals? As I told earlier, they will have, right, same size, shape, energy, etc. And also they'll try to imitate like their atomic orbital. So S is spherical in shape, P is dumbbell in shape, right? So we are using one of this and 3 of them, right? So then what happens? It will have properties of both, means it will be almost spherical but a dumbbell, right? A larger lobe, smaller lobe, larger lobe, smaller lobe. Same way we have 4 of them like this, right? So this is where you see the probability of finding electron will be maximum. That means what? You see the electron is present here and then it is going to share with the incoming hydrogen atom like this. Since it is head-on overlap, right? It's a head-on overlap. What we are going to get here is a sigma bond. So by this we can decide that the carbon is sp3 hybridized and the bond angle here is 109 degree 28 minutes. And what is the shape of the molecule? It is tetrahedral in nature. This is how we do sp3 hybridization for alkanes, to be specific, methane molecule. Now let's see for alkenes and alkynes, which is sp2 and sp respectively. For ethene molecule with the molecular formula C₂H₄, the carbons are sp2 hybridized. Both the carbons are sp2 hybridized. How to prove that? Look at this carbon. It is approached by 3 atoms, 2 hydrogen and carbon. Same way with respect to the other carbon. That means what? The carbon is approached by 3 atoms, so it should be ready with 3 hybrid orbitals. So what happens? 2s and 2p orbital, right? All these 3 will undergo mixing. And what we are going to get now? 2 plus 1 is 3. And what sort of hybrid orbital? sp2, s1, p2. 3 sp2 hybrid orbitals will be formed. What about this? We call this as unhybrid, or simply it is a p orbital. So it will remain as it is. So how to write the hybrid orbitals for this carbon? You see 3 hybrid orbitals like this. Right? All of them stay as far as possible from each other, and all of them have 3 electrons like this, right? And then what happens now? It is ready to overlap with the incoming atom. You see this carbon is approached by the other carbon here, right? So that is also sp2 hybrid orbital, right? So the larger lobe is the one which will participate in bond formation, right? So this will undergo head-on overlapping and again it will form a sigma bond, right? What about here? We have 4 hydrogen atoms, right? All of them will approach head-on and it's going to share the electrons. Since it's sharing the electrons here, it's forming sigma bonds, head-on overlapping, right? But what we have not accounted so far is this unhybrid orbital, right? Like this. So it also has 1 electron. Then what happens? It will undergo sideways overlapping. So because it's forming sideways overlapping, it's going to form a pi bond. So pi bond, it's nothing but a double bond like this. You see, the molecule will have a trigonal planar. So how trigonal planar? Like this. A trigonal planar structure, and the bond angle is expected to be 120 degree, right? Similarly, right, for this the carbon is approached by 2 atoms. So 1 carbon, 1 hydrogen, 2 hybrid orbitals. So how many we are going to get? 2 and sp hybrid orbitals. So how do we write this? As far as possible like this, because of the repulsion of electrons, and both of them are hybrid sp hybrid orbitals, and we have 1 electron here, 1 here, and both of them have shared. That means 1 sigma bond. And you see there are 2 hydrogen atoms approaching, right? Like this. What they are going to form? They are going to form a sigma bond. What we have not accounted so far is there are 2 unhybrid orbital, right? Say if this is 1, right? So this one I'm talking about, it will undergo sideways overlapping to form a pi bond. What about the other one, right? They are parallel to each other and again they share the electron sideways. So 1 more pi bond. That's why in ethyne molecule, right, here there will be 1 sigma, the rest 2 are pi bonds. So by looking at the structure of the molecule, you can say that the bond angle here is 180 degree and the shape of the molecule is linear because it is linear. Thank you for watching this video. Until next time.